And next, because Dale really wants to see the table view, we're going to
Yes.
move over to the non-spatial to spatial section.
Oh, you're spatializing for me.
Yeah, so here what we're going to do, and we're going to show you another neat way to bring up the viewer, or the data inspector, is you can click on a input feature and go inspect, and it will come up with the
Yes.
correct writer. Now in this case, it doesn't remember all of the username stuff, so we'll throw that in. And this is the address points table. So now this is the table viewer.
I do love the table viewer.
We've just added. So this is non-spatial data. So by default, if there's nothing to show spatially, we bring up the table view. And this shows you standard sort of table view, and you can scroll through and see all the information in its native state.
I bet you can actually click on a heading and sort too. Have you ever tried that?
Nope. Let's give it a shot.
Looks like that already might have been sorted that way.
Okay, let's sort by zip code then. Aha.
Yes, it all works.
That is nifty.
Okay, that's great, Dave.
And we've established that that is indeed non-spatial data.
Yes.
And what we're going to do is we're going to run it through a few transformers to spatialize it.
Yes.
Now, I should have left it up, but we can also see here all of the attributes that are attached to it.
There's an X chord and a Y chord down in there.
Yeah, these are going to be very useful coordinates, or a very useful piece of information. So what we're going to do is we have we're going to rename a few attributes first to
match your desired output schema, I guess.
Exactly. Then we can use a 2D point replacer, taking the X coordinate and Y coordinate. What this will do is take those values and create a point at that location. So it's turning non-spatial coordinate information into a true geometry.
Dave, they want us to zoom into the bookmark there.
Okay.
So you can see.
To zoom in, zoom out, you can use this nifty little slider here.
Yeah, so go in a little bit and then slide her on over.
There we go.
Look at that. Wow, that's cool.
Yeah, okay.
I guess some of our pro services folks are needing stuff a little bigger to read.
Yeah, I know I'm getting old, and I require those big 27-inch monitors. Hint, hint. So now the 2D point replacer gives us a basic geometry, but anyone in the GIS mapping field knows the geometry doesn't mean anything unless it's attached to coordinate systems, so you know where in the world it is. So the next step is we use a coordinate system setter, and we know this data is in Texas, so we give it the Texas state plane central foot coordinate system. And there's a whole list of coordinate systems to choose from here. So I think there's 3,000 or 4,000 odd. So there's oodles, in other words. So because there's so many, we actually give you a nice little filter down here. So if we want all the ones that are in Texas, we can just type TX.
And Texas gets a lot too.
Yep.
It's a big place.
Also, if you know the EPSG number,
yes,
you can just type that in, and it will find the EPSG number coordinate system and its corresponding FME native coordinate system as well. Okay, so
you're setting it. That must mean that the Teradata is going to remember the coordinate system.
Yeah, it's coordinate system aware.
Very good.
So now let us run this section, and we'll. Oh, the other thing I did here is this is a very large table, and we're kind of short on time. So there is a section in the reader where you can set the rows to read at a time. Oh, sorry, not the rows to read at a time. Yeah, you can set the rows to read at a time, which gives you your transaction size.
Right, that's a bulk read thing.
Yeah, but what you can also set is maximum features to read. And this is handy if you're prototyping or workbench. Yes. You got 3.5 million records in your table. It's going to take a long time to test it out. So you can just set maximum features to read to 1,000, and that gives you an idea of what's going on and not take up too much time. So I've done that, and we will run this.
So we're going to grab the first 1,000 basically, and you're spatializing them. Oh, you're still rereading those AutoCAD ones, I guess. You didn't disable them.
Yeah, I did not disable the reader. Just
okay, there it goes.
Okay, nice. So we're going to have a look at these.
Address points geog got 1,000.
Yeah.
I can tell from the stats. I love those stats.
Oh yeah, I guess I should point that out. Okay, well we'll load this up first. Teradata spatial.
I wonder what your password is.
Well, I used to like better when dev was less to type, but We
There
pick
we
the
go.
address points, and we'll load that up.
So this should be some point geometries. And I'm going to,
So
okay.
there's our first 1,000 points essentially. And if we look at one of those points over on the screen here, we'll see that they have all the fields that the
And
original
I'm
data
pleased
has.
to see Texas 83 Central.
Yeah, it's got the coordinate system is stored, the FME point geometry is stored, and all of the attributes are stored. So that's your basic spatialization.
Good. So we took non-spatial stuff in Oracle, spatialized it. Now, I don't think you're going to talk about geocoding today, are you, Dave?
No.
But
No,
that
we're
is
not.
something that is another way. In this case, the input data had an X and a Y value, so we could spatialize. But there are ways in FME to use external services from other vendors to geocode, which means to take an address and then find out where that really is on the Earth. So in particular in Canada, DMTI has a great geocoding thing built into FME. We're working right now with our friends at Esri with ArcGIS Online, has a really good geocoder. So if you have an ArcGIS Online account, we'll be able to make use of that. And our friends at Pitney Bowes with their Spectrum geocoding thing, where we've got a prototype underway for that too. So all of these are ways in the middle. Basically, one of these blue boxes of Dave's would say DMTI or AGOL or something like that, geocoding. You pump your data in with the address, and out comes the spot on the Earth, and an indication if it worked or not, because there's bad addresses out there, and then if it's bad, you can route that somewhere else to.
Yeah, throw in a tester to test your results, see if you get a good address, and then root it up. We'll actually show some QA options coming up in some of the next workspaces.